Hi, everyone. Welcome to the RMET's Virtual Student and Early Career Scientist Conference 2020, and thank you for joining us today in Poster Session A. I'm your chair, Kris Boykin, a PhD student in meteorology at the University of Reading. I'll be introducing our 4 poster presenters one at a time, and they'll each have 3 minutes to give us a brief overview of their work, then 2 minutes for questions. Now, Demio doesn't allow us to zoom in on the posters, so please down those posters in the handouts section when they're uploaded to get a better look. Only the presenters will have access to their microphones and webcams, so when you have a question, please just type it into the chat and I will pick which questions to answer. All right, now it's time for our first presenter, Emily Ball. Emily, please introduce yourself and tell us about your poster.
My name is Emily Ball. I'm a PhD researcher at the University of Bristol in the School of Geography. And my research is looking at the driving mechanisms of polar vortices in extreme climate scenarios. So today I'm going to be talking about Mars's annular polar vortex, which is really interesting because it's annular, which has been shown to be a barotropically unstable state. This is different to Earth's stratospheric polar vortex, which is has potential vorticity which increases monotonically to the pole. So if we look at my poster, you can see in section 5 we've got a figure of the polar vortex on Mars, which you can see that the annular structure is remarkably persistent in the reanalysis data. So I'm really interested in looking at the structure and variability of the vortex. And there's sort of 2 main mechanisms that we think are driving the vortex on Mars. So we've got latent heating from carbon dioxide condensation at the pole. So when the winter pole gets cold enough, you get carbon dioxide in the atmosphere condensing, releasing latent heat, which warms the pole and causes destruction of PV at low altitudes. And you also have dust storms on Mars. So you get global dust storms approximately once every 3 years on Mars. So if you look in figures 1 and 3, you can see in Martian year 28, it's quite different to the other years. And this is possibly, we think, due to the fact that a global dust storm hit during the winter solstice. And so a global dust storm, basically what we think happens is it causes atmospheric heating at higher altitudes than normal. And this extends the Hadley circulation, and you get the enhanced descending branch of the Hadley circulation causing warming at the pole, which also causes destruction of PV, which is why you can see in Martian year 28 that the polar vortex has almost completely disappeared. So my research will basically focus on sort of like an attribution study of the various driving mechanisms of the polar vortex on Mars. So I'm using this flexible model called ISCA, which currently doesn't include any representation of latent heating or dust. So I will be adding these into the model to try and more accurately capture the sort of structure and variability of the polar vortex on Mars. And I'm hoping this is going to be really useful for both planetary scientists who are interested in sort of Mars's atmosphere in particular, but also Earth-based dynamicists, because there are a lot of comparisons that you can draw between Earth's atmosphere and Mars's atmosphere. So, for example, I've said that Earth's stratospheric polar vortex isn't annular, but actually the mesospheric polar vortex is annular in PV. And also, it's sort of thought that possibly dust storms on Mars act in a similar way to volcanic eruptions on Earth. So you have this, release of aerosols into the atmosphere, causing sort of disruption to the polar vortex in that way. Yeah, so I'm hoping this will just sort of contribute to general understanding of vortex dynamics. Thanks for listening, and I look forward to questions.
Great, thank you so much, Emily. So now we're on to questions. Let's see what we got. We have a question here from Tom. Are there any similar events on Earth beyond volcanic eruptions?
I'm not sure about events particularly, but I guess you have similarities between sort of zonal, hemispheric asymmetries on Earth and Mars. So you have on Earth, you've got hemispheric differences in the polar vortices, and that's mostly due to the topography differences. And this is similar to on Mars, and the polar vortices on Mars are quite different in the two different hemispheres there. But I can't think of any specific events off the top of my head.
Great. Oh, and I had a quick question for you as well.
Yeah.
How do you think your research is going to affect, say, future missions to Mars, be it an actual manned mission or perhaps more probe missions?
Ooh, that's a good question. I'm not entirely sure it'll be super useful, unfortunately, as much as that breaks my heart a little bit. I'm using a very idealized model, so I don't think I'll be able to, draw any specific conclusions about very, particular areas or anything like that. But it'd be interesting to hopefully advance sort of understanding of the atmosphere on Mars in general. But I don't know how it would help influence any future missions, unfortunately.
Gotcha. That's a good answer. Does anyone else have a question for Emily? We have a few seconds left before we go ahead and move to our next presentation. No, I don't see any more in the chat. So thanks very much again for your presentation.
Thanks.
And
Thank you.
We'll go ahead and move to our next presentation, which will be Emma Sanig. Emma, could you please come up or rather turn on, sorry. Please present yourself and tell us a bit about your poster and your work.
Hiya, yeah, so my name is Emma Sanig. I'm currently studying an MSc in Applied Meteorology and Climatology at the University of Birmingham. But today I will be presenting some work I did as part of my undergraduate dissertation at the University of East Anglia. So my project was exploring the smaller scale precipitation response to El Niño in the maritime continent, specifically looking at areas where the precipitation response doesn't really match up with the general trends that would be expected during an El Niño. So in the maritime continent, there's typically drier conditions than usual during El Niño events in association with the shift in the water circulation over the Pacific Ocean, creating a large area of subsidence over the maritime continent. And in figure 1, I have plotted daily average anomalous precipitation for 3 El Niño events over the December, January, February season using data from the Tropical Rainfall Measuring Mission. And these maps highlight regions where there may be little or no change in precipitation during an El Niño event, or even places where average precipitation increases. And these were the places that I really wanted to look into in more detail. So I picked 5 specific locations, which I've marked on figure 1A, and looked at whether the precipitation response is consistent between different El Niño events, and also tried to understand what are the meteorological drivers behind the response found. So to do this, I built up a picture of the anomalous circulation patterns influencing the maritime continent during an El Niño event. So in figure 2, I looked at a 2015-16 El Niño and looked at meteorological variables such as anomalous sea surface temperatures, 850 HPA wind direction and speed, as well as convergence and divergence at 850 hectopascals. So this data was really useful for looking at large-scale circulation patterns during El Niño events, monsoons, and pressure distribution over the maritime continent. So we found that the circulation patterns during each event were as expected, with a large area of divergence and subsidence of air over the central maritime continent, as well as suppression of monsoon winds over Australia. So I don't have much time to go into each specific location, but I have put a couple of examples on the poster. But generally, each location was really influenced by large-scale changes in circulation patterns, particularly the effect that this has on wind direction, whether that be through anticyclonic systems in the northwest or anticyclonic systems over Australia. And changes in wind direction were also really interesting in how they interacted with small-scale processes such as land-sea breezes and orographic lift, which was really important mechanisms for precipitation in the maritime continent generally. So yeah, that's what I found. Thank you for listening.
Ah, that was brilliant. Thank you, Emma. So does anyone have any questions for Emma? Emma, I'm hoping you can explain to us a bit more about figure 2 and tell us a little bit more how that works.
So these are just daily anomalous conditions for one event, the 2015-16 El Niño event. So they were calculated by looking at an El Niño event and a La Niña event of similar scale. So it's El Niño minus a La Niña for each meteorological variable. And these were just used to see what was happening in terms of circulation and how might this affect how this affects precipitation.
Oh, brilliant. We also have a question from Tom here. How do you define the similar scale?
So these were, I used the Oceanic Niño Index, which looked at El Niño events and La Niña events in terms of sea surface temperatures. So it's how large, so it's how big a difference the effect was on the sea surface temperatures. So they sort of matched them up in terms of strength.
Brilliant. And I've got one more quick question for you. Does this relate to your ongoing research as part of your master's, or do you hope to look into this topic further?
It doesn't really. I'm looking at droughts at the moment in North America throughout the Holocene, so it's a bit different. But there was a lot more that I wanted to do with this if I had the time, particularly looking at smaller scale processes in much more detail, because the data I had wasn't really of a high enough resolution to look at that kind of thing.
Oh, brilliant. Great. Thank you so much, Emma.
Thank you.
And we'll move on to our final presenter. So that'll be Lakshmi Kalavappilly Sajan. Lakshmi, if you can come up and introduce yourself and then tell us about your work.
Hi, everyone. My name is Lakshmi Kalavappilly. I'm studying Master of Research in Climate and Atmospheric Sciences in the University of Leeds. So today I'll be presenting the study of diurnal cycle of precipitation over southern India in Indian summer monsoon. The Indian summer monsoon brings in the major part of annual rainfall into the Indian subcontinent. So various studies have shown that majority of rainfall occur over the western coast. And one of the main reasons for this is the presence of Western Ghats, a long range of mountains having a length of about 1,600 kilometers in the north-south direction and an average elevation of 1,200 meters. So diurnal cycle of precipitation during monsoon is highly influenced by Western Ghats. So mechanism of diurnal cycle over land is generally understood, but the timing of the cycle and the mechanism of propagation of convective systems is not well understood and is not represented well by the current models. So in this study, a monthly analysis is done for the region marked in red box in figure 1A, where the green shaded region represents the Western Ghats. The reason for choosing this region is first, there's a major low mountain pass with an elevation of about 140 meters. And second, the highest peak of Western Ghats is present in this region. The precipitation data is taken from GPM iMerge version 6 data sets from June to September, which is the typical monsoon months. The analysis is done for 20 years, that is from 2000 to 2019. And I have constructed Homoler diagrams, which is averaged over 20 years and accumulated within 24 hours. The data is averaged over latitude to see the propagation of diurnal cycle along longitude. Which is shown in figure 2. The black lines in figure 2 indicate the western and the eastern coast, and the white dashed line indicates the gap, and a yellow dashed line indicates the highest peak. So it is seen that diurnal cycle peaks along the western coast during night and early morning, and over the gap during the afternoon. The diurnal cycle is propagating east towards land, but the strength weakens once it crosses the highest peak. So by midnight, over the eastern coast, the diurnal cycle is strengthening again. So some observations noted here are, as you go from June to September, though the highest precipitation accumulated over the western coast and the gap is decreasing, the precipitation accumulated over land east of the peak is increasing. And the strength of the diurnal cycle over the eastern coast is happening sooner as you go from June to September. Hence, a major question arises here is that whether another diurnal cycle is initiated over the eastern coast and propagating east along with the diurnal cycle that is coming from the west. So this question will be addressed in my future work. And the next step is to analyze the frequency of rainfall to see whether this high precipitation accumulation over the western coast and the gap, is it because of high intensity of rainfall or because of high frequency of rainfall? Also, other two major objectives of this project are to analyze the impact of intra-seasonal oscillations and monsoon depressions, which foam over Bay of Bengal, which lies in the eastern end of the Indian subcontinent on diurnal cycle during monsoon. Thank you.
Apparently I had my mic muted. Sorry about that. And we have a question for you, Lakshmi. Here we go. Are there any initial ideas for why this might be about the earlier strengthening of the diurnal cycle through the monsoon months? Oh, Lakshmi, we're unfortunately able to hear you. Are you muted? Ah, yes, much better. Thanks much.
That's one of the objective of my study, and well, I feel that it could be because of since it's a coastal region, and we're not sure about it. I have to work on that more in my study.
Great. Okay, and I've got another question for you. So how do you plan to explore the impact of intraseasonal oscillations or depressions in your work?
Okay, so I will be, about the monsoon depressions, I'm planning to take the data sets from ERA interim, and my major idea will be to divide the monsoon months of my analysis based on the monsoon depression and the intraseasonal oscillation days, and see how it varies the diurnal cycle.
Great. Do we have any more questions for Lakshmi? Okay, I don't see any more questions coming through at the moment, so we'll go ahead and wrap that up for questions. And this now brings our poster session to a close. On behalf of the Royal Meteorological Society and all of our attendees, I'd like to say thank you again to our presenters for your time and presentations. And it's now time to break for lunch. Enjoy the rest of the conference, everyone, and I hope to see you later at poster session B at 1 p.m. Enjoy your lunch break.